Hello everyone, welcome back for another lesson with rational expressions. In this video we'll definitely be multiplying expressions, and we'll check our time to see if we can do the division of irrational expressions in the same one. We might split it, we'll see. Alright, so to multiply a rational expression, the first thing that you have to do is, you guessed it, factor everything. GCFs, trinomials, difference of two squares, grouping, factor everything, the entire fraction, numerator and denominator. Okay, the next three steps, you can change the order. This is just how I have them listed. So then we would multiply everything together in the numerators, straight across, and everything together in the denominators, straight across. Now don't actually distribute, just multiply all of those factors together, keeping them in their parentheses. Okay, that way we can then truly see what the common factors are in the numerator and denominator and reduce them or cross them out. All right, now after you factor the entire expression, if you see those common factors and you want to reduce them first, you can, and then multiply what's left over in numerator and denominator. So here's our first example, and the first thing that we're going to do is read through and look to see what do we need to factor. All right, so the numerator of the first one is 2 divided by x minus 2. That is multiplied by the quantity of x squared minus 4 divided by 4. Okay, there is nothing right now that you can simplify. The x minus 2 and the 2 can't be reduced because they're not exactly the same, and same with the terms in the next one. However, this numerator of the second fraction has two terms. One of them is squared. So I'm first going to check for a GCF, which is a big fat no. And then next, because it's two terms, I'm going to look to see, is it a difference of two squares? Can I take the square root of x squared? Yep, it's x. Can I take the square root of 4? I sure can, it's 2. So those factors of the numerator will be an x plus 2 and an x minus 2. So here's everything factored. Original fraction multiplied by the factored numerator over the denominator of the second expression. Okay, now at this point, don't forget, we've got excluded restricted values of the domain we need to take care of also. So we're going to look at the terms of the denominator, set them equal to 0. There's only one term, the x minus 2, that has an x. I don't have to worry about the 4. So we're just going to set x minus 2 equal to 0 and get that excluded value from the domain of our function. So x can't be 2 when we solve. Okay, now let's multiply. I'm going to multiply everything straight across in the numerator and denominator. And really the terms in the denominator, their order just changes. Okay, so I've got the 2, the x plus 2, the x minus 2 in the numerator all multiplied together. And then 4 multiplied by that quantity of x minus 2 in the denominator. Now we can truly see what factor is identical that we can reduce. It's the x minus 2. Okay. And then after we reduce that x minus 2, we also can reduce the 2 and the 4. 2 divided by 2 is 1, and 4 divided by 2 is 2. So we really have, in our factors, we have an x plus 2 left in the numerator and a 2 in the denominator, giving me x plus 2 over 2 as my final answer. There's nothing more to simplify, gang. We can't reduce the 2's because I've got something else added to it in that numerator. Okay, so it's x plus 2 all divided by 2. Okay, great work with that one. Let's try another one. X plus 3 divided by x squared minus 4. Oh, we just factored that one. Great. That one's a difference of two squares. We'll take care of that in just a second. And then the next fraction we're multiplying by is x squared minus x minus 6 over x squared plus 6x plus 9. Okay, so we got to take care of those and do a little bit of work for them. So the numerator is factors of a and c multiply to give me negative 6, and that coefficient of our b term is negative 1. So what multiplies to negative 6 and adds to negative 1, that'll be a negative 3 and a positive 2 over x's. So my factors should be an x minus 3 and an x plus 2 for the numerator of the second fraction. Okay, denominator of the second fraction, So I'm taking the coefficients of A and C, 1 and the constant, 1 and 9. What multiplies to 9 and adds to the coefficient of the middle term, B, which is 6. 3 multiplied by 3 is 9. 3 plus 3 is 6. So that actually is a perfect square if you recognize it. You can write it as x plus 3 two separate times, or you could write it as the quantity x plus 3 squared. But for what we're doing, I think we want to go ahead and leave it in that factored form. All right, and don't forget, just make sure that you remember this one. The difference of two squares from the denominator of the first fraction will be an x plus 2 and an x minus 2. So we kind of got a lot. All right, here's everything factored. X plus 3 over x plus 2, x minus 2. Multiplied by x minus 3, x plus 2 in the numerator, x plus 3 in the denominator. Okay, now again, take everything in the denominator, set it equal to 0, and find those excluded values. So we have an x plus 2 set equal to 0 to get negative 2, x minus 2 set equal to 0 to get the negative 2, and then we have the same factor for the last one. X plus 3 set equal to 0 gives us a negative 3. Okay, now we're going to multiply. Now I'm going to make it a big mess, and then we'll reduce common factors. All of the terms in both numerators get multiplied together. All of the terms in the denominators get multiplied together. Again, I didn't distribute, I just wrote them all together with their parentheses showing multiplication. Now let's reduce common factors. Okay, I see x plus 3 is a common factor. I've got 1 in the numerator and 2 in the denominator, but I can only reduce 1. And then I also have the x plus 2 in both numerator and denominator, so that's reduced. And then nothing else can be done, so I have an x minus 3 in the numerator, and both quantities multiplied, x minus 2 and x plus 3 in the denominator. This is our final answer. Whew, that was a lot of work for that one. Now again, we can reduce before we multiply. That might make it a little easier. We'll try that in another example. Okay, number 3. X squared minus 81 divided by x squared minus 18x plus 81 all over x squared minus 9x. Now, I wrote it as a fraction. In your stuff, it just has x squared minus 9x, but I want us to remember that does have a denominator of 1, so I wanted to see it as a fraction. Okay. The numerator of the first fraction is a difference of two squares. So its factors will be an x plus 9 and an x minus 9. Okay, denominator, we're going to look to see what multiplies to 81, a times c, and adds to the b, negative 18. 9 times 9 is 81, but that gives me positive 18. So I need a negative 9 multiplied by a negative 9. And that gives me the negative 18 when I add. So x minus 9 and an x minus 9. Okay, cool. In the next expression, it's two terms, so I'm going to look for difference of two squares. That's not going to work because I can't take the square root of the 9x part, so I should go back and do a GCF. It has a GCF of an x multiplied by an x minus 9, and again, put that dude over a baby 1. Okay, so here's all of my factors together. X plus 9, x minus 9 over x minus 9, x minus 9 multiplied by x minus 9 all over 1. Okay, if we multiply it all together, you're going to see, oh no, I'm sorry, we forgot to do restricted values. Darn! Here we go. Denominator set equal to 0. We only have one term, x minus 9. When I set it equal to 0, I'll get positive 9 as the restriction. Okay, now multiply it all together. And I didn't change the order of anything. Normally, I would take that x that's by itself and I would put it in the front, but it truly doesn't matter because now we're going to reduce. Okay, what are common factors? That's right. I got an x minus 9 I can reduce. And I have another x minus 9 I can reduce. So what does that leave us? That leaves us with an x multiplied by the quantity of an x plus 9 all over 1 or just x multiplied by x plus 9. There you go. You got that one. We are all done. All right, we're going to go ahead and stop the video here, and we'll come back and do division by itself. Thanks, guys.